Good day, everyone. Welcome to this u-blox webinar on precise positioning and why is it a key enabler for smart agriculture. My name is Arnaud Lelanik. I am responsible for business development at u-blox, and also I am a couple of years at the company. I still lack a lot to see and learn from the final users. And while preparing this slide, obviously I could not go in the field to watch farming operation. But what I observed is whatever technology is bringing us, enabling autonomy, efficiency, flexibility is still essential. Because here in winter, the tractors are converted into snow cleaning machines to clean up street and parking areas and contributes to traffic safety. Today, we will divide the presentation into four main sections. In the first one, we will look at trends and challenges faced by agricultural sectors. In the second part, we will look at application and requirements toward positioning and particularly precise positioning. In the third section, we will talk about technology, how to address those different requirements, and finally, I will give you a snapshot of u-blox offering fitting into these market needs. Population is still increasing. Also, the pace is slowing down, with almost 10 billion of people looking for food, energy, infrastructure. We have a couple of unknowns in the equation to resolve. And one very important is how to supply food to each of us, producing and delivering the right quantity, minimizing the waste, losses over the entire chain, and therefore starting from the field. Population is growing, but interesting observation is that since 2000, we use less surface to produce this food. And on the orange line, you see that also we use less surface. We have been able to keep increasing food production and yield since 2000. Regionally, we observe as well some more uncertain events impacting the harvest year on year, increasing amount of flooding or dry period, which also become longer. Unfortunately, I do not have data here to show what is the real impact on that, but obviously evolution of technology allow us to keep production growing. Now, if we look specifically at the workforce doing the job, we see that those are steadily declining since years, and in all parts of the world. In many countries, this decline could be correlated with the beginning of industrialization from the 50s, but it seems that for the recent years, other factors are coming into game. Another contributing factor is that the rural population growth has been slowing down steadily until 2015, and it has recently flattened. So this limit of population is putting pressure on all industry in the rural area, and the agricultural sectors is obviously one of the first impacted. If we look closer at this workforce, you see that this workforce is relatively old, and the proportion of young and next generation is rather small. With an average of 55 years globally, most farmers are closer to retirement than beginning of their career. The working conditions are also a barrier to attract new generation as the job attractiveness is suffering. According to the US Bureau of Labor Statistics in 2019, for example, agriculture and related industry full-time workers on average worked 47 hours a week. In comparison, non-agricultural workers worked 42 hours a week. Another number is like 20% of agriculture workers reported 60 hours of overweek compared to 6% for non-agricultural workers. Not to mention that this work is quite physical. It is showing how difficult this job is attracting. Governments are now looking at ways to increase the amount of farmers within the young generation. For example, EU is targeting to double them by 2040. Looking at the proportion currently, you see that only 12% are under 40. So there is a really pressure on the industry to make the job more attractive. Now that we looked at the human and workforce side, let's look at the earth resources aspect. Why do we use fertilizer, pesticide, growth regulator, and biostimulants? Fertilizers are here to boost crop growth and yields. It is our answer to compensate natural soil replenishment, which is too slow for modern yield farming. Pesticides are here to prevent crop losses, stabilize food supply. It protects the plant from pests, disease, and weeds. Growth regulators are here to improve resilience and productivity. because they modulate metabolic processes of the plant. The usage of all this chemical is having a huge financial impact. Global agriculture uses millions of tons of chemical fertilizer and pesticide annually. And this is really widespread, even if we see a recent decline due to better technology and integrated pest management. The massive use of this product is also having a huge cost impact and sustainability impact, bringing pressure and driving adoption of precision agriculture to minimize this chemical use. On top of that, this usage has a strong impact on us, on runoff, water and pollution, soil degradation, and human health. The use of fertilizer causes nutrition runoff, leads to eutrophication and deaths of zones in water bodies. Pesticide harms aquatic life and pollinator. The use of all these products is also leading to soil degradation. Overuse of chemicals brings acidity, reduced biodiversity, and impaired long-term fertility. Finally, speaking about human risk, is improper use of pesticide is leading to acute poisoning and chronic health issues. All in all, these factors must be converging to a strong drive of evolution toward technology. And precise positioning is part of the solution. On the workforce side, the work is done faster and independently during hours, while reducing the physical strain on workers. When farmers can organize and orchestrate the overall work, his machines are autonomously taking care of his field. On the yield, cost, and environment side, autonomous and semi-autonomous machines, drones, enable the execution of the work with optimal efficiency, saving on time, energy, operating night and day. And precise equipment affect positively the consequence on environment as they allow to operate on the right spot, using the right amount of consumable and water. This is why we believe precision technology is part of the answer. Now that we looked at challenges and trends in agriculture, we will map them to some application examples which are enabled by positioning technology and specifically precise positioning. Yield monitoring and mapping is about combining yield monitoring measurement with GPS location data to create a spatial map showing how productivity varies across the field. It is one of the pioneer applications in smart agriculture, and as of today, having limited precision requirement. The harvester was rather big, and mechanical instrument is difficult to be very precise with such a traditional equipment, even equipped with high precision GNSS for guidance. So going forward, different scenarios will be possible as requirement might increase. The machine will allow smaller resolution and precision, or the usage of precise drone and imagery will help to be more precise and enable optimal soil analysis and therefore replenishment, or even plant-specific care. So today the systems are using GNSS or SBAS to enable this 1 meter accuracy, but going forward we should go below the meter precision accuracy. A second application is a kind of direct application of yield mapping, is to facilitate or accelerate soil replenishment according to the need. Here, the accuracy requirement will vary. It will vary depending on the equipment and the technology used. Older equipment will be working with a range of 1 meter or below. Going forward, it will decrease to improve the effectiveness. So centimeters down to 5 is a good ballpark, and it shows that system type will require the usage of correction services like PPP, Calibras, Madoka, or Baidu B2B, or even RTK for higher precision going forward. When 30 centimeters will be good enough for some implements when using drones, autonomous drones, or beyond visual line of sight drones, the accuracy requirement will increase in the range of 5 to 10 centimeters. In a similar way, the update rate requirement will vary proportionally to the possible speed of the equipment. The next application, which is UAV drone-based mapping and scouting, is having as the strictest accuracy requirement the final processing of the collected images. Historically, post-processing or PPK was commonly used to avoid usage of local base station or expensive correction data services. With new available options, we see that the usage of RTK or even PPP-RTK is getting traction. Ultimately, the strict need is on being able to reach the best accuracy to post-process the collected data and images. Nevertheless, the better are the input data and the more precise is the drone navigation, the better will be the overall result. In some cases, drone use for mapping can be the same as the drone used for other tasks like spraying. In any case, this often implies autonomy or beyond line of sight navigation. In that case, the regulation requirement does not specify a strict accuracy to fulfill the safety, but detection and risk mitigation aspect often motivate the use of RTK or PPP RTK for precise navigation. The next application we will look at now is precision planting. Current new generation of tools allow row spacing of about 30 centimeters and a place from seat to seat of about 15 centimeters. To allow the tractor to precisely come back and drive between these rows and possibly distribute fertilizer or biostimulant at the same location, the requirements are definitely going below 50 centimeters. Such a task being quite complex compared to tilling, for example, it requires perfect alignment, and some implements will use a precise positioning from the tractor, if possible, but some other implements will come with their own positioning system. This allows them to compensate or make sure the needed accuracy is available. You will also find systems where GNSS is a reference and some inertial navigation sensors are used in the heads to detect the movement and orientation of different seeders. Obviously, there is an integrated control which is coming to the cabin to enable the farmer to monitor the operation. The last application we're going to look at today is about driving assistance or even autonomy going forward. The tasks are here multiple: tilling, planting, spraying, harvesting, or even syncing tasks like unloading the harvester while the harvester is harvesting. So you have the tractor which is driving next to the harvester as close as possible at a synchronized speed. If two humans would have to synchronize these two machines, the challenge would be huge, the stress on the driver will be increasing, and the risk of accident relatively big. So to control machine and have them operate in close vicinity, precision and situation awareness at a fraction of a second is essential when it comes to autonomous or assisted driving. That's why an accuracy of below centimeters is very important. If you look at most modern autonomous systems today, they need this reference accuracy because they have a radius, an awareness radius of up to 25 meters. Of course, GNSS here is extended with different sensors like LiDAR or still cameras and hundreds of sensors, but the reference parameter is really key, and the position given by the GNSS is a reference for the entire system. Last but not least, when you have an autonomous machine, as a farmer, you don't want the machine to be down in the field. Otherwise, you will have to go to the field. You need the machine to operate, enabling you to focus on other activities which are to be done by the human. I hope you like this overview of application example with estimated accuracy requirements, which basically show us that most of the case below 1 meter accuracy is required. In the following slide, we're going to see how to make this possible. Let's start with the basic. 20 years ago, we had, or 20 years and 1 month ago, we had GPS L1 only available on Earth. In December 20 years ago, GPS turned on the second band. And meanwhile, Galileo, Beidou, GLONASS followed to deploy each of them their constellation. Being single band or multi-band with one or more constellation is nevertheless not enough to go below 1 meter. While it is very good for asset tracking, aftermarket telematics, or wearable devices, it is not suitable for high precision use cases like autonomous vehicles, precision agriculture, service robots, where low accuracy is required. And now, if you want to go below 1 meter, correction data are required. On this new slide, we are going to see why correction data are required. why we only get meter level accuracy in standalone GNSS receiver. As you see here, the signal makes its way to the receiver. It passes through various atmospheric layers, including the ionosphere and troposphere. Both affect signal propagation and introduce measurement error that standalone GNSS receivers are not able to correct on their own. It is basically the same for satellite orbit error and satellite clock error. Consequence of these errors is that you get a reduction in measurement accuracy. This limits the receiver to provide only meter level accuracy. The only way to correct this different source of error is to get the correction information from a different source. If you look at what are the different options of correction, you might see different characteristics coming with different level of performance like accuracy and time to fix mode, or the time needed to reach precise positioning. We mostly characterize the options in three groups, from the most precise and fast to the least precise and the slowest. So you will find RTK using OSR, PPP RTK with SSR model, or PPP also using SSR. These are three different kinds of observation or representation. OSR is basically a representation specific to the receiver position and providing the different error correction, satellite clock, orbit, and bias, together with the delays of the different layers in one package. SSR, state space representation, is a bit newer method used mostly in PPP and PPP-RTK, which provide for each error type a separate correction, including satellite position, clock correction, and code biases. It allows the receiver to locally compute the needed correction on its own. We say that SSR is more suitable for global application because you are less relying on network density and potential error of single base station. SSR allow individual error correction, update rate, and offer advantage like network redundancy and reduced impact from reference stations error. It has been seen as more efficient and scalable technology than OSR, with benefit in performance, user capacity, and bandwidth usage. Now we see as well that correction or precision is often correlated to network density behind this technology. RTK is implying a high network density to operate, while PPP is modeling the situation between the different base station and enable the usage of least dense network base station. Finally, the difference between PPP-RTK and PPP is the level of correction provided. You see that in PPP you often do not get all the details about the different layers. We spoke about standard precision positioning, we spoke about correction data and why they are needed. Let's look now at the benefit of all bands. So as I said before, 20 years ago we had GPS L1 only. Now we have 4 global constellations, a couple of more regionals, and each of these constellations is broadcasting signals on multiple bands. Having access to all these constellations in all the bands is bringing you access to the best availability of the best accuracy. Having access to all the band is a way to compensate or deal with any evolution of the condition, get some noise coming into the application, surrounding the application, entering areas where maybe the open sky view is not for granted anymore. You can change the weight given to different frequency and help you compensate and keep the accuracy at the best. One of the benefits of having access to all bands is that you also get access to L bands or frequency used to broadcast the correction data, like PPP services, Galileo WAS, Madoka, BioB2B. And this PPP will also be part of enabling mass market application. Last but not least, it's enable GNSS integrity. It's a good way to be able to detect any spoofing or jamming attack. What we have on top of us is just remarkable. I think we can even speak about revolution. Think about it. 20 years ago, there was GPS L1 only. And now we have GPS, Galileo, Baidu, GLONASS, L1, L2, L5, L6, L-band, This altogether is enabling an infrastructure which is reliable, redundant, free, and globally available. I think it's just amazing. And now, on top of that, we can even get the famous correction data from satellite directly to the receiver. I think we can really speak about the revolution because from meter accurate positioning, we are now able to do precision positioning, resilient positioning, and this is scalable. This amazing infrastructure we have on top of us is a key enabler of u-blox vision to democratize high-precision GNSS to the mass market. u-locate is a perfect fit for smart agriculture going forward. We have been pioneer in bringing access to high-precision technology to the mass market. With our u-blox M8, our u-blox F9, and our u-blox 20 family, we continue this path, bringing new technology evolution and higher performance going forward. Our current offering is a combination of our advanced high-precision receiver, together with high-performance antenna, best fit correction services, which have been designed and tuned towards the best altogether, rounded with an access to our long and leading expertise in GNSS. This longevity is also materialized by our offering and ownership of the entire stack, silicon and algorithm. Looking backward, we can even say that all our generation were more than a decade available for purchase. And this is not going to end now. In 2025, we brought to the market the next step of our vision, ZX20P. It is a concentrate of u-blox IP, from silicon, algorithm to module design. Its small form factor enables you to navigate using all the band of all constellation and even get correction data directly from the satellite, being u-blox offering or third party. This is very important because it enables high precision where cellular connectivity is not available, and it enables high precision without the need to deploy and maintain an own network around the farm and the field. X20 is also bringing a world-leading RTK, PPP, RTK, and PPP support, including Galileo has, enabling you to select the right service for the right application. Going forward, security is key. Confidentiality, integrity, and authentication from satellite to host. X20 can detect intentional or unintentional spoofing or jamming event, as well as secure the delivery of the right information to the right host. Last but not least, the single chip design is making of X20 a very robust and reliable device, perfectly suitable for harsh requirement and condition of agriculture activity. Think about it. We often take about automotive as a reference for quality and reliability. When it comes to agriculture, the conditions are much more difficult. The importance of uptime is as well essential for optimal and smooth operation of the farm. And this is possible only if your hardware is offering you high reliability and robustness. Having the best GNSS receiver is essential to precise positioning. And having the right antenna in front is not less important. Every single piece or part of signal not captured or degraded by the antenna cannot be recovered or compensated and used by the receiver. GNSS signals are very weak when they reach the surface of the Earth, and making sure to capture them with the best level of quality is essential, especially when you want to achieve precise and stable high precision accuracy. At u-blox, we realize that antenna selection is often a challenge for our customers, and we have been looking to support them. Find the best trade-off, large bandwidth to cover all bands, best performance at an affordable price was until recently almost mission impossible. And because it was mission impossible, when we worked on X20, we decided to work as well at the perfect fit in terms of antenna, enabling a fast testing, a fast validation and integration in high precision GNSS for most applications. The result is this RMB2, which is a perfect match with our receiver, giving access to the best trade-off performance and cost. On top of that, with its ruggedized package and different mounting options, this will be the perfect fit for requirement of smart agriculture application. In case not, you can still look for different technology, different dimension, weight, etc. And this antenna can be used as a reference to make sure you reach the best level of performance. at the correct price. This easy-to-use, reliable all-band antenna is part of our offering. It enables maximum position availability, high performance, different mounting options, easy deployment, and will cover all bands to navigate and get the correction. Speaking about correction, enabling fast centimeter level positioning services is the third pillar of u-blox offering. It is available in three different flavors: Point Perfect Live, Point Perfect Flex, and Point Perfect Global. Going from the most demanding requirement in terms of accuracy and conversion time up to the most demanding requirement in terms of easiness of global scalability. Point Perfect Live is enabling down to 1 to 2 centimeters in 10 seconds. It is based on a local high-density RTK network, suitable for the most demanding application, looking for highly reliable, dependable network. Point Perfect Global, on the opposite side, seamlessly worldwide available, enabling down to 10 centimeters in 2 minutes wherever you are. In the middle, Point Perfect Flex is a trade-off. It is continentally available, enabling continental scalability and flexibility for a huge range of application, and is a base trade-off between performance and price. It allows down to 3 to 6 centimeters in less than 30 seconds. As I mentioned before, these different services are a trade-off between top-notch accuracy and global availability. And this is what is reflected here, with Point Perfect Live being available where high density networks are available, where Point Perfect Global is available anywhere on Earth, providing centimeter or tens of centimeter level accuracy, even where RTK network density is least or not available. We now have been through our offering, and I would like to go with you through different slides illustrating how this offering and the development behind it matches with market and application requirement. In order to do that, we all have to go through the customer journey at least once.
We want to collect data for our R&D, for performance analysis.
We run some test campaign to go through this customer journey and record file, allowing us to retest and improve our algorithm. In this particular example, you see that we collected data using a spraying drone, and instead of loading it with liquid, we loaded it with our hardware and solution. The X20P EVK, an MB2, our measurement tools, and connected it to our correction services. Let's look at the test result of this flight using ZX20P. The idea here is as well to enable customer to understand the difference between two services kind. And here we compared Point Perfect Live, our VRS OSR based correction services, versus Point Perfect Flex, our PPP-RTK SSR based services. You see that with Point Perfect Live, we are reaching below 2 centimeters 1 sigma and below 4 centimeters in 100% of the position, while with Point Perfect Flex, we are more in the ballpark of 3.5 centimeters 1 sigma and maximum 6 centimeter accuracy. I think this is a good illustration of what you can expect from different kind of services and accordingly decide what is the best fit for you in terms of accuracy. As part of trying to go through the customer journey, having the use case of being in a perfect open sky for a drone is probably the main usage, especially in agriculture. Now it can come to operation where you need to fly in an environment where you have trees, you have boundaries, which will be an obstacle between satellite and the vehicle. For that, we have been as well testing under trees and here using Point Perfect Live. And you see that thanks to a multi-band or an all-band, all-constellation receiver combined with Point Perfect Live, we are able to maintain a position fix of 10 centimeters or below 10 centimeters. Also, the sky visibility is obstructed. I hope you enjoyed the session with me today and that the topic we went through brought you some valuable information. If you need some more information about u-blox, about precision agriculture, our point perfect portfolio, all band benefits, or in general technology, feel free to access our resources and get in touch with our local support.